Today we are going to solve systems of equations by substitution. So when we look at an equation and it's got this big brace around it, that typically told us before we've got to graph these two equations on the same coordinate plane. Well, here we're going to solve by substitution, algebraically rather than graphically. So you see how y equals x minus 2. Well, we're going to take this expression of x minus 2, since y equals it, and we're going to put it in place of the other equation. So we'll go ahead and rewrite this second equation, but in place of that y, I'm going to write x minus 2. And this equals, and it equals negative 2x plus 1. Well, from that point, we can go ahead and do some opposite operations. We can get x by itself. And we'll do that maybe by subtracting this x from both sides. And I can also subtract this 1 from both sides. So let's see what we're left with when we do that. Well, here we've got the same sign, so we've got negative 3 when I collect those two numbers. Here, when I combine these, I end up with a negative 3x. I do that opposite operation of dividing by negative 3, and we get our answer. So x equals 1. Well, that's only one component of the ordered pair. I need both components. So now we've got a choice. We can either take this 1 and put it in for the x in the top equation or the bottom equation. Well, it doesn't matter which one you put it in. You're going to get the same answer either way. So I always pick the easiest one, and the easiest one looks like that top equation. Y equals x minus 2, but in place of x, we're going to take that 1 and put it in place of it. So we'll go ahead and rewrite what we've got. We've got now y equals 1 minus 2. Well, that just equals negative 1. So we've got our answer, and we write the answer as an ordered pair, x comma y. So x was 1. Y was negative 1, and that's our answer. So we've got one answer. Let's one down, 2 to go. Let's take a look at the next one here. Here, a little bit different situation. We have one with y equals x plus 3, but the other equation doesn't have y by itself. But that's okay. All you need is one of the variables solved for. It doesn't matter whether it's y or x, as long as it's by itself. We can use substitution. We can take the y value, which is x plus 3, and put it in place of the equation below. So what do we have? Well, we've got this 2x, but in place of y, I'm going to write down what y is. Y is x plus 3. And this all equals 6. This is the hard part that a lot of people get a little confused on. And all we're doing is rewriting this bottom equation. See, it's exactly the same. The difference is right here. See, in place of this y, I put what y is. So y is x plus 3, it says. So that's why I put x plus 3 here. Well, we can go ahead and collect some like terms. See, there's no number in front of the parentheses or in front of the behind the plus sign, so that just means it's 1, and we can collect those two terms and then subtract the 3. And so what we're left with is a 3x equals 3. Well, we just divide by the coefficient of x, which is 3, and we've got the x value. So x equals 1. Well, that's just the x component of the ordered pair. We still need y. So let's just take that 1 and let's just put it in place of that x in that top equation. So let's just go ahead and rewrite that top equation. Y equals, but instead of x, let's write 1. 1 plus 3 is 4. We've got our answer. 1 comma 4. And that's it. That's where the two lines end up crossing, just like we found yesterday. Well, here's another problem. And here, instead of y being by itself, we have x by itself. So this time, instead of the expression going in for y, we're going to put it in for x, because x equals 6 minus y. Well, this one's a little bit more difficult because we have that negative 2 in front of the x. That means we need to take negative 2 and multiply it by x. So to show that being done, I'm going to rewrite what I have, y minus 2, but I'm going to put parentheses around that 6 minus y. And then this all equals 3. The reason why we do that is because I need to distribute this negative 2 over that difference and then collect terms. So what I've got now is y minus 12 plus 2y, and this all equals 3. So I'll go ahead and isolate my variable by doing an opposite operation, add 12 to both sides. I'm also going to collect some like terms, the 2y and the 1y. And so what I've got all together is 3y equals 15. So one final step there, at least to solve for y, and that is to divide by 3. So now we have y equals 5. Well, again, that's only one component. We still need to find the x value. Well, where do we put that 5? Right here. It doesn't matter which equation you put it in for, either the y up on the top equation or the y on the bottom. It's just I picked the bottom one because it's easier. See, all I have to do is subtract that y value from 6. So x equals 6 minus y. Well, y is 5. That's why I put it there. And then I do that one operation. That gives me 1. So x equals 1. So there's my answer. It's an ordered pair, 1, 5. Those are some examples of the substitution method being used to solve systems.